Hello there, and welcome to the Science for Sleep Hub, that quiet corner of the internet where the universe slows down just enough for you to breathe, where curiosity finds its peace, and where science's greatest ideas are told softly, the way they always should have been. Tonight, we are going somewhere extraordinary together, not somewhere that asks anything of you, not somewhere that requires you to think too hard or stay too alert. Somewhere that will carry you, gently and without rush, through the deepest story there is. Tonight, we will drift through the universe itself. Not just a piece of it, not just a galaxy, a star, or a corner of the night sky, but all of it, from the very first moment of existence, when there was no space, no time, no darkness, no silence, all the way to right now, to this breath, to wherever you happen to be. Before we begin, I'd love to know something simple. Where are you listening from tonight? Are you tucked into a warm corner, the day already fading behind you? Maybe you're somewhere unfamiliar, a hotel room, or a place that doesn't quite feel like home yet, looking for something steady to hold on to. Or perhaps you've been here before, returning to this kind of calm, the way you return to a favorite place. Wherever you are, I'm glad you found your way here. And if this journey through the cosmos helps your thoughts slow down, helps your body remember how to rest, I'd be so grateful if you liked this video or subscribe to the Science for Sleep Hub. It's a small thing, but it helps this quiet corner reach others who might need it too. Now, let your eyes close if they want to. Let your shoulders drop. Let the weight of the day settle somewhere other than you. The universe has been waiting 13.8 billion years to tell you this story. And tonight, there is nowhere else to be. Before anything existed, there was something even harder to imagine than nothing. There was no space. There was no time. There was no darkness, because darkness requires space to exist within. There was no silence, because silence requires time to pass through. Whatever came before the universe began is not something human language was built to describe, and that's all right. We don't need to exhaust our minds trying to fully understand it tonight. We only need to know this. At one moment, the moment we call the beginning, something changed, and from that change, everything followed. The universe began approximately 13.8 billion years ago. That number is so large it resists being felt. If you tried to count to 13.8 billion one number per second, without stopping, without sleeping, it would take over 400 years. That is truly vast. The entire recorded history of human civilization is only about 5,000 years long. The universe is nearly 3 million times older than that. You are, in truth, a very recent development in a very old story. In the first fraction of a second after the beginning, the universe was not dark. It was unimaginably, brilliantly bright. Not bright the way a lamp is bright, or even the sun bright in the way that all the energy that would ever exist in everything was compressed into a space smaller than a grain of sand, into something dazzling and overwhelming. Temperatures exceeded anything that exists anywhere in the universe today. The laws of physics as we understand them barely held together. Space itself was just beginning to mean something. And then, in an instant, it expanded. Not an explosion the way we usually picture one, not fire spreading outward through space that already existed. This was space itself stretching, becoming, growing in every direction simultaneously, with no center and no edge. In the tiniest sliver of time, the smallest imaginable fraction of a moment, the universe expanded from something unimaginably small to something unimaginably vast, and as it did, it cooled. And in cooling, it began to settle into something that physics could describe, something that existed. Of course, you were not there. Neither was anything you have ever known. But the atoms that make up your body were, in a sense, already present, not as atoms yet, not as anything recognizable, but as the raw energy that would eventually become everything. The universe was not yet a place, but it was becoming one. Within the first 3 minutes, the universe did something that would quietly shape everything that followed. As it expanded and cooled, the lightest atomic nuclei began to form. Hydrogen nuclei, single protons, formed first, then helium, then a trace of lithium. That was it. 3 elements, in roughly 75% hydrogen and 25% helium proportions. Everything you have ever seen or touched, iron, carbon, oxygen, gold, none of it existed yet. The universe had only just begun its chemistry lesson. There is something quietly wonderful about those first 3 minutes. The universe, in its very earliest moments, made exactly the ingredients it would later need to build stars. The simplicity of those early moments was not a limitation. We might call it a kind of patience. The universe was laying its foundations slowly. For the next 380,000 years, the universe remained opaque. It was filled with a hot, glowing plasma, a fog of charged particles so dense that light couldn't travel more than a short distance before scattering and changing direction. There was light everywhere, brilliant and continuous, but it could go nowhere. It was trapped, bouncing endlessly through a sea of charged particles. The universe was bright, but blind. Then temperatures dropped to around 3,000 degrees, still hotter than the surface of most stars, but cool enough for a critical change. Electrons slowed down and were captured by atomic nuclei. Hydrogen and helium atoms formed for the first time, complete and stable, and in forming, they cleared the fog. It was a truly epic sight, worth witnessing. Suddenly, light could travel, the universe became transparent, and the light that had been trapped in the plasma for 380,000 years was finally free. It streamed outward in every direction, carrying the imprint of what the universe looked like in that exact moment. That light is still traveling right now. As you breathe quietly, and the world outside grows still, that ancient light is passing through the room where you are lying. It has been stretched by 13 billion years of cosmic expansion into long, cool microwaves. We call it the cosmic microwave background, the oldest light in the universe, the oldest signal of any kind we can directly observe. A faint, smooth glow from the universe's first moment of clarity, still resonating quietly through everything, gently encompassing you too. After recombination, the universe entered a period cosmologists call the Dark Ages. The universe was now transparent, but there were not yet any stars, no galaxies, no new sources of light. The hydrogen and helium filling space drifted in vast, slowly thickening clouds. The universe was profoundly dark. Not the darkness of a room with the lights off, where the walls still exist and a thin line of light slips under the door. This was a darkness with nothing in it. Vast, cold gas clouds slowly falling toward each other in a universe that had not yet learned how to shine. The Dark Ages lasted perhaps 200 million years. 200 million years of silence and gathering. Clouds of hydrogen thickening and warming at their cores, invisible gravity doing its patient work, matter settling into the gravitational valleys left behind by those first ancient plasma fluctuations. And then, somewhere in the dark, in a cloud of gas that had grown dense enough and warm enough at its heart, the first star ignited. We have never directly observed these first stars, but we can infer what they were like, and what we infer is extraordinary. The first stars in the universe, astronomers call them population 3 stars, formed from pure hydrogen and helium, with no heavy elements at all. Without the cooling effect that metals provide, these first stars could grow to enormous sizes. Some may have been hundreds of times the mass of our Sun. These stars burned hotter, brighter, and faster than we might expect, living for only a few million years before dying in spectacular explosions. Those deaths were among the most important events in the history of the universe, because in their cores, these first stars had been forging heavier and heavier elements. And when they died, when their outer layers exploded outward, those elements were scattered into the surrounding gas. For the first time, the universe contained carbon, oxygen, nitrogen, silicon, iron, the ingredients of planets, the ingredients of life. Every carbon atom in your body was forged in a star. The calcium in your bones, the iron in your blood, the oxygen in every breath, all of it was made inside a star that lived and died before our Sun was born. You are not separate from the universe and its history. You are, in truth, a continuation of it. As the first stars lived and died, their light began to change the universe around them. Bubbles of ionized gas grew around each star, expanding outward, eventually merging with the bubbles of neighboring stars. Stars began appearing across the cosmos, gathering in the first small proto-galaxies, merging and growing. The first galaxies were small, irregular, lumpy things, dense concentrations of young stars and gas, chaotic and bright. And while all of this was happening, the cosmic web itself was taking shape. Gravity had been organizing matter into a vast structure of filaments and voids. Galaxies kept forming along those filaments, clustering at their intersections. Between the filaments lay vast, empty spaces stretching for hundreds of millions of light years. If we could see the entire universe at once, it would look like an enormous three-dimensional web, or the branching structure of neurons in a brain, or the threads of a mycelium network spreading through soil. The largest structure ever woven, built from nothing but gravity and time. And you are somewhere inside it, breathing slowly, drifting towards sleep, made of the atoms this web spent billions of years arranging. Let your body grow heavier. There's nothing you need to think about, nothing you need to chase right now. Let the thoughts still moving in your mind slow down the way ripples in a pond slow when no new stones are thrown. The universe has been expanding for 13.8 billion years and will keep expanding long after tonight. There is no urgency here, only depth, only time and peace. We are still early in tonight's journey. Our Sun has not yet formed. The Earth does not yet exist. Life has not yet been invented. All of that is still ahead, still slowly gathering in the gas clouds of young galaxies. But we have time. We have all night. Even in those early billions of years, the universe was not the violent place we might imagine. The dominant quality was not violence, it was patience. Gravity is the weakest of the fundamental forces, but it is the force that shapes the universe on the grandest scales, and gravity is infinitely, profoundly patient. It draws every particle of matter in the universe gently toward every other, continuously, in every moment. Those slight density increases in the early universe were enough for gravity to do its work. Over hundreds of millions of years, those slight increases became filaments, clusters, and galaxies, not through sudden events, but through long, quiet accumulation. If you let yourself feel that, there is a deep calm in it. The greatest structures in the universe were built by the gentlest force, working over the longest time, not in haste, not in urgency, only through patience and continuity. The universe does not rush. Tonight, neither do you. As you drift, consider this. The light reaching your eyes from stars you may have seen tonight has been traveling for years, hundreds of years, thousands of years. The faint smudge of the Andromeda galaxy is the light of 1 trillion stars that left its source 2.5 million years ago. That is truly remarkable. When that light began its journey, our ancestors were among the first Homo species walking the African savanna, still hundreds of thousands of years away from fire, from language, from everything that came after. That light kept crossing the void through all of that time, through the rise and fall of every human civilization. And now, tonight, some of those photons are landing on the surface of a planet that didn't exist when they left, caught by the eyes of creatures that didn't exist when they left, and carried by optic nerves to brains, thinking, thoughts. The universe had never thought before. You are the universe noticing itself. Not a metaphor, not a poetic flourish, a physical fact. The carbon forming your neurons was made in stars. The oxygen sustaining your brain right now was scattered by supernovae. The hydrogen in your body is almost as old as the universe itself. You were assembled from the oldest matter in existence, arranged briefly and improbably into something that wonders about where it came from. The universe spent 13.8 billion years making you. Tonight, it would very much like you to rest. Right now, something else is happening in the universe worth knowing about. This is the story of dark matter, one of the quietest stories in all of science. Most of the matter in the universe, roughly 85% of it, is not the kind that makes stars, or planets, or you. Dark matter emits no light. It absorbs no light. It passes through ordinary matter as though ordinary matter isn't there. Right now, as you lie still, billions of dark matter particles are flowing through the room, through the walls, through the floor beneath you, through your body itself. They do not slow down. They leave no trace. They simply continue flowing through everything in the universe made of ordinary atoms. They do this patiently, invisibly, and on an enormous scale. Most of the universe is something we cannot see, cannot feel, and do not yet understand. And yet the world keeps turning. Stars keep forming. Galaxies keep growing. You keep breathing. Darkness, in all its forms, is not hostile. It is simply the larger part of everything, the part we haven't yet learned to read. About 9 or 10 billion years after the Big Bang, A cloud of gas and dust in an unremarkable arm of an unremarkable galaxy was disturbed. A region of the cloud began to collapse under its own gravity, slowly at first, then faster and faster. At the center of that collapse, a protostar was forming. The surrounding disk was quietly doing its own work, particles sticking together, growing from dust grains to pebbles to boulders to planetesimals, the building blocks of planets. At the center, the young sun kept growing, hotter and hotter, until hydrogen nuclei began fusing into helium. The sun turned on. That event, quiet and unremarkable on cosmic scales, was the beginning of everything that has ever mattered to you. Because orbiting that young star, a small planet was forming. It would survive heavy bombardment and enormous collisions, and eventually, about 4.5 billion years ago, the Earth was there. I imagine you would have wanted to witness that moment. Solid, cooling, wrapped in a thin, hot atmosphere. Still lifeless, but already carrying the chemical ingredients of what was to come. The universe had spent 9 billion years building toward this moment. It had simply followed the laws of physics, and those laws, given enough time and enough hydrogen, had led here. Feel the length of all of that. 9 billion years before the Earth existed. Another 4.5 billion years since. Right now, you are at the very latest point in that story so far. You carry, in your atoms, the memory of everything that came before. The hydrogen in your body is primordial. It formed 3 minutes after the Big Bang and has been part of the universe ever since, in stars, in gas clouds, in oceans, in rain, in other living things, and in you. You are not new. You are ancient matter, briefly and beautifully arranged. The universe has no center. Or rather, every point is equally the center. When space began expanding, it did not expand outward from a single point. There was no larger space to expand into. Space itself is what expanded. Every region moved away from every other region simultaneously. Every observer, everywhere in the universe, sees the same thing. Everything moving away, the universe expanding in every direction. Every point is the center. No point is uniquely privileged. You are at the center of the universe. So is everyone you have ever known. The universe has been holding you in place quietly, without effort, since before you were born. It held the atoms that would become you for billions of years. There is nowhere for you to fall out of. No edge to slip over. Only space continuing in every direction. And you resting somewhere in the middle of all of it. You are not small in a big universe. You are part of the big universe. All the way down, all the way through, all the way back to the first 3 minutes when the hydrogen in your body was new. Close your eyes. Let yourself be held. For now, just rest. Your mind can drift in and out, catch fragments, lose whole sections to sleep, and find yourself somewhere different when you surface. That is exactly as it should be. Settle in again. Let the day recede a little further. Let your body remember that it doesn't need to be doing anything right now. Soften your jaw. Open your hands. Let your breath find its own rhythm, slow and easy. The way it moves when you're not thinking about breathing at all. Now we return to the universe's story. A young sun had just ignited. A small rocky planet was cooling in the third orbit. Everything that has ever mattered to you was about to begin, but not yet. Not for a long time yet. Let us continue. The early Earth was nothing like the world you know. Imagine the surface of a planet where the ground itself is still half molten in places. The sky thick with carbon dioxide and water vapor. The sun visible through a hazy sky but slightly smaller and cooler than today. No oceans yet, or at least no continuous ones. No land masses in the sense of stable continents. Heat everywhere residual from the collisions that built the planet, still warming the rock from within. That was the Earth about 4.5 billion years ago. It is almost impossible to love, looked at this way. And yet this was the place where everything that would follow spent its incubation. Within a few 100 million years, conditions changed enough for liquid water to persist on the surface. And liquid water brought out something the universe had rarely, if ever, seen before. A stable, warm, chemistry-rich environment where organic molecules could form and interact across enormous spans of time and enormous variety. We don't know exactly when life began on Earth. The oldest evidence accepted by scientists dates to about 3.5 billion years ago, microfossils, from what is now Western Australia. But there are hints that life may have appeared even earlier, perhaps 4 billion years ago. If so, life appeared on Earth at the earliest possible moment it could have. This is either an extraordinary coincidence, or it tells us something important, that when the right conditions exist, life arising may not be so improbable after all. The first life was nothing you would recognize. No cells with nuclei. No multicellular organisms. Just simple prokaryotes, single-celled beings, the distant ancestors of the bacteria that still live in the soil and on your skin today. They did not move mountains or change the sky. They simply existed. But they were alive. And in being alive, they were doing something that, in all 13 billion years of the universe's history, nothing else we know of had managed to do. They were producing interestingly varied copies of themselves. In the most minimal sense, they were evolving. For about 2 billion years, not much changed at the level of visible complexity. Life remained microbial, single-celled, but it was doing extraordinary things, quietly, slowly, transforming the chemistry of the oceans and the atmosphere while appearing from the outside to simply be sitting there, silently reshaping the planet. The most important of these invisible transformations was the production of oxygen. About 2.4 billion years ago, in what geologists call the Great Oxidation Event, oxygen produced as a metabolic byproduct by cyanobacteria began accumulating in the atmosphere for the first time. Before this, the Earth's atmosphere contained very little free oxygen. After it, oxygen became a permanent component of the air. This was catastrophic for most life that existed at the time. But for organisms that evolved to use oxygen in their metabolism, it opened an entirely new world of energetic possibility. Oxygen-breathing metabolism is dramatically more efficient than anaerobic alternatives. The future of complex life of fish, of insects, of mammals, of you, was built upon this ancient metabolic revolution, begun by tiny bacteria in a shallow sea 2.5 billion years ago. There is a patience worth pausing on in this story. 2 billion years of microbial life, slowly changing the chemistry of a planet. No drama, no visible progress, just chemistry, continuing. Just cells, dividing. The universe is patient beyond anything we can imagine. The life it produced learned patience from the source. The first oceans were warmer and chemically different from today's, richer in dissolved iron, more acidic in places, but they were vast. In their depths, in the chemical environment where water met rock, in the energy around hydrothermal vents, the conditions necessary for life were not only present, but stable. The ocean is patient in a way the land is not. It buffers temperature changes, it dilutes toxins, it carries nutrients across enormous distances. In many ways, it is the most forgiving chemical environment on the planet's surface. And when life found it, it stayed there for a long time. Think of the ocean at night. The surface dark and nearly still. Below it, the world of slow currents and gradual pressure, of cold and silence, of particles drifting gently through millions of meters of dark water. The deep ocean floor is one of the least disturbed environments on Earth. Sediment in some deep ocean plains has been accumulating undisturbed for tens of millions of years. The deep ocean is older than almost anything you could visit. In a sense, it is something like the universe thinking slowly. Life began in something like that, in silence, in slow chemistry, in darkness. About 1.5 to 2 billion years ago, something happened that changed everything again. A large cell appears to have engulfed a smaller one, and instead of digesting it, kept it alive. The smaller cell was incorporated into the larger one, and eventually became what we call the mitochondrion. The mitochondrion, the organelle, inside your cells that converts nutrients into the chemical energy your body runs on. Every cell in your body contains hundreds or thousands of mitochondria, each one the descendant of that ancient incorporated bacterium. They still carry their own small loops of DNA, the quiet echo of the moment when two very different organisms became one. This event, endosymbiosis, allowed the evolution of eukaryotic cells, far more complex than anything that had existed before. And eukaryotic cells eventually made multicellular life possible. Every plant, every fungus, every animal, every visible living thing is made of eukaryotic cells. The history of life is full of moments like this. Events that look like accidents but turn out to be the most consequential things that ever happened. The meteor that ended the dinosaurs. The mutation that gave some ancient vertebrate a slightly more complex limb bone. Life is a story of contingency, and yet here you are. The specific combination of events that led to you stretches back billions of years through an unbroken chain of ancestors, every single one of whom lived long enough to reproduce. Not one of your ancestors, in 4 billion years, died before having offspring. That chain is unbroken from the first cell to you. You are the current end point of the longest unbroken success story in the history of this planet. Let that settle quietly for a moment, not as pressure, but as something worth resting inside of. Somewhere between 600 and 800 million years ago, the first multicellular animals appeared. Soft, simple, strange things without hard parts, without eyes or mouths drifting or crawling in the shallow oceans of a world where life had not yet reached land. Then, about 540 million years ago, the Cambrian explosion happened. In a geologically brief window of time, the basic body plans of almost all modern animal phyla appeared in the fossil record. Eyes, mouths, hard shells, jointed limbs, nervous systems. The diversity of forms that would eventually lead to fish, insects, spiders, vertebrates. all of it visible in rough prototype in the Cambrian. After 500 million years of bacteria and early eukaryotes, life on this planet became suddenly complex, and it stayed that way. Once life found complexity, it held on to it. 540 million years have passed since the Cambrian. In that time, at least 5 mass extinctions occurred. The most severe may have killed 96% of marine species. The Earth was nearly emptied of complex life. The survivors refilled it. Evolution continued. The extinction 66 million years ago ended the dominance of the non-avian dinosaurs. Small, warm-blooded, probably nocturnal mammals, the ancestors of all mammals alive today, survived the chaos and eventually diversified. Whales descended from land mammals that returned to the sea. Bats developed flight. Primates appeared in the trees. Around 300,000 years ago, according to current scientific understanding, a species of primate emerged in Africa with cognitive abilities that allowed for complex tools, abstract language, and the transfer of knowledge across generations. Scientists call this species Homo sapiens, the group to which modern humans are generally believed to belong. Modern civilization is only about 10,000 years old. The Industrial Revolution barely 300 years behind us. The age of spaceflight shorter than a human lifespan. But in that brief window, this species mapped the genome, detected gravitational waves, and photographed black holes. These were significant developments in the history of humanity. You are part of a species that has looked back 13 billion years and understood, at least partially, what it saw. That is not a small thing. It may be the most extraordinary thing that has ever happened in the known universe. And right now, none of that is your concern. Right now, your only task is to breathe and to let your body do what it evolved to do magnificently over hundreds of millions of years, which is to sleep. Your ancestors were sleeping long before they developed language or tools. Sleep is older than consciousness, not a weakness. One of the most important things a body does. Your brain contains roughly 86 billion neurons. Each neuron can form thousands of connections with others. The number of possible states of a human brain exceeds the number of atoms in the observable universe. The universe built something in you that is, in some ways, more complex than itself. Not in scale you are small, the universe is vast. But in the density and complexity of information, your brain is like nothing else we have ever discovered, and right now, it is preparing to rest. The neural activity that sustains wakefulness is slowing. Let your thoughts go. The universe is 13.8 billion years old. You are, in cosmic terms, brand new. The atoms that make up your body are ancient, some billions of years old, but the specific arrangement called you has existed for only a few decades. That is not a sad thought. It is a quiet and rather beautiful one. You don't need to carry the weight of cosmic history on your shoulders right now. You haven't missed anything that came before you. You arrived exactly when you were meant to, when the universe had arranged itself, through billions of years of patient chemistry, into conditions that made you possible. And right now, the universe has arranged itself so that you are lying down, somewhere warm and relatively safe, breathing slowly, listening to a voice trying to help you sleep. This is enough. More than enough. For now, let the long story of life on this planet spread over you like a blanket. 4 billion years of chemistry, evolution, patience, and improbable survival, all of it connected through an unbroken chain, reaching all the way to you. You are both very ancient and very new. As you can see, a great deal has happened in cosmic history, and right now you are the matter that became you. Sleep now. The universe will still be here when you wake. Every star visible to the naked eye is in our galaxy, the Milky Way. The nearest star is about 4 light-years away, a faint red dwarf called Proxima Centauri. The light from that nearest star takes 4 years to reach your eyes. The light from stars you can barely make out at the edge of your vision on a dark night may have been traveling for thousands of years. Our galaxy contains between 100 and 400 billion stars, a massive barred spiral about 100,000 light-years across. If you could see the Milky Way from outside, it would look like a pinwheel glowing brightest toward the center where the stars are most dense. We can't see it from outside. We are inside, embedded in one of its arms, looking simultaneously outward, inward, and sideways. Away from city lights, on a clear night, the Milky Way appears in the sky as a faint, milky band of light, the combined glow of hundreds of billions of stars, too many to see separately. Every culture throughout history has had a name for it, a story about it, a way of making sense of that soft river of light across the night sky. And beyond our galaxy, there is more. The Milky Way is one of more than 50 galaxies in what we call the local group. The Andromeda Galaxy is about 2.5 million light-years away and is, remarkably, visible to the naked eye on dark nights as a faint oval smudge. The light from Andromeda reaching your eyes tonight left its source 2.5 million years before our species existed. That soft smudge in the sky is not the light of a single star. It is the light of trillions of stars, averaged and compressed and dimmed by distance into something barely visible. And it has been traveling without interruption since long before Homo sapiens took their first steps on this planet. The universe is not abstract. It is always, in some sense, right there in the light that reaches your eyes every night, in the atoms that make up your hands. The universe is not something you visit or imagine. It is something you are made of, embedded in, and will always be part of. Even now, even in the dark, even in sleep, especially in sleep. What sleep researchers call hypnagogia, the threshold state between waking and sleep, happens in the quiet minutes before sleep in the brain. Thoughts become less linear, images appear without context, connections form in strange and soft ways. A face you haven't thought of in years, a color with no name, a sound you can't quite place. This threshold state is, in some ways, the most creative state the brain regularly enters. You don't need to linger there tonight. You can fall the rest of the way. Let loose associations drift past without catching them. Let images form and dissolve. Let the thoughts still arriving slow further and further still, until they become the quiet background noise of a mind almost at rest. Somewhere, the universe is still expanding. Galaxies are still drifting apart in the dark. Somewhere, a star you will never see is ending its life as a supernova tonight, scattering heavy elements into a gas cloud that will one day become new stars and new planets, and perhaps, billions of years from now, something that wonders about the universe just as you do. The cosmic microwave background is still passing through you just as it has passed through every surface on this planet for 4.5 billion years. Too faint to feel, too ancient to imagine, still carrying the memory of the universe's first moment of transparency. All of it continuing, all of it patient, all of it here. And you, on the threshold of sleep, gently dissolving into the dark. Let go. Let the universe hold what you let go of. It was doing this before you were born, and it will keep doing it long after you wake. Rest now. Right now, somewhere in the Milky Way, a star is being born. A cloud of gas and dust is being drawn slowly inward by gravity toward its own center. It has already been collapsing for hundreds of thousands of years. It will take hundreds of thousands more before fusion begins. When it does, a new star will ignite. It may burn for 10 billion years. It will know nothing. It will fear nothing. It will simply burn steady and continuous for longer than the current age of the universe. And you, within one human lifetime, will look up and wonder. There is a word for what you feel when you think about that. Perhaps awe, or something quieter, a kind of settling. The feeling of being very small in a very large place, and finding, surprisingly, that it is not frightening but restful. The universe is as vast as your problems are genuinely small within it. Tonight you don't need to carry the weight of the cosmos. The cosmos carries itself as it always has, as it always will. You only need to breathe, and then breathe again. And then let the breathing carry you, gently and without effort, toward sleep. The universe will do the rest. Now just let yourself settle, and let the words pass through you the way water flows through a channel, not something to direct or catch, just something flowing. Let us move slowly. There is no hurry. In this final section, we move outward again. We leave the timeline of biology and return to the cosmos as it is tonight, and then move forward toward the deep future waiting for it. We will visit the farthest edges of what we can see, the strangest objects we have found. And then we will return to the quiet of home, to this room, to this breath, to this moment. The universe is currently about 93 billion light-years across, at least, the part we can observe. The universe is 13.8 billion years old, so you might expect the observable universe's radius to be 13.8 billion light-years. But the universe was expanding while that light was traveling. The regions of space from which the oldest detectable light came have moved much farther away since that light left them. The edge of the observable universe, the farthest distance we can hope to see, is now about 46 billion light-years away in every direction. Beyond that edge, the universe almost certainly continues. Those regions of space did not disappear or collapse. They simply exist beyond our cosmic horizon. There are galaxies there, perhaps infinitely many that we will never see, not in principle, not with any instrument of any imaginable power. The universe has horizons, just like oceans have horizons, not walls, but the limits of perspective. This is a beautiful thought to carry into sleep. The universe is larger than you can imagine, and most of it is beyond your reach, and that is entirely fine. You can simply be inside it, small and warm and temporary, and that is more than enough. Our galaxy, the Milky Way, is about 100,000 light-years wide and about 2,000 light-years thick. Through its disk, it contains between 100 and 400 billion stars. At its center, lies a supermassive black hole called Sagittarius A, containing about 4 million times the mass of our Sun. Our solar system orbits the galactic center from about 26,000 light-years away, completing a full orbit every 225 to 250 million years. The last time our solar system was roughly in the position it occupies tonight, the Triassic period was just beginning on Earth, and the ancestors of the dinosaurs had just arrived. Before that, it was at this same point, during the height of the Cambrian explosion. Before that, in the depths of the Precambrian, when life was still entirely microbial. The galaxy has been our home for the entire history of complex life on this planet, and we have barely moved within it. Beyond the Milky Way, we are part of the Laniakea supercluster, a vast network of galaxies stretching about 520 million light-years across. Laniakea contains the mass of roughly 100 quadrillion suns. It is one of the largest known structures in the universe, and the largest thing we can credibly claim to belong to. You are part of the Laniakea supercluster. In the broadest sense, that is your address. And in a small corner of one spiral arm of a fairly ordinary galaxy in the outer reaches of that supercluster, orbiting a middle-aged star on a rocky planet, you are lying down, breathing slowly, letting the day's tiredness ease away. The universe is not still. While you sleep, it is not sitting quietly waiting for you to observe it again. It is expanding. Every galaxy beyond our local group is being carried away from us by the expansion of space itself. The farther away a galaxy is, the faster it recedes. This expansion is driven by what we call dark energy, perhaps a property of space itself, causing space to expand at an accelerating rate. Dark energy makes up about 68% of the total energy content of the universe. Dark matter makes up about 27%. Ordinary matter, everything you can see or touch, makes up only about 5%. Dark energy was only discovered in 1998 when two independent teams of astronomers found that the universe's expansion, rather than slowing as expected, was accelerating. The discovery was so unexpected that it took years to be fully accepted. We are still very early in our understanding of the cosmos. What we know is extraordinary. What we don't know is larger still. The night sky you see when you step outside on a clear evening is not the universe as it currently is. It is the universe as it was. The farther you look, the further back in time you see. The moon is about 1.5 seconds in the past. The sun is 8 minutes in the past. The nearest stars are years in the past. The Andromeda Galaxy is 2.5 million years in the past. The faintest galaxies visible to the Hubble Space Telescope are billions of years in the past. The James Webb Space Telescope has detected light from galaxies that existed when the universe was less than 300 million years old, less than 2% of its current age. When astronomers look at the most distant objects we can observe, they are seeing the universe in its infancy. Small, irregular proto-galaxies, forming stars at furious rates, embedded in a universe denser, hotter, and more chaotic than the one we inhabit today. The universe has been expanding, cooling, and thinning for billions of years. What we see around us now, the majestic spiral and elliptical galaxies, the quiet intergalactic voids, the slowly expanding cosmic web, is a universe in what might be called middle age. Past the explosive youth of its first billion years, not yet entered the long, cold decline of its distant future. We live in a privileged moment. Stars are still forming, galaxies are still active with stellar birth and death. In the far future, this will not be true. The universe will wind down, slowly and thoroughly. But strangely, there is a kind of peace in that too. The far future of the universe unfolds across timescales that ordinary numbers struggle to carry. Let us move through them gently, like turning the pages of a very long and very quiet book. In about 5 billion years, our Sun will exhaust the hydrogen in its core. It will expand into a red giant, its outer atmosphere swelling outward past the orbit of Mercury, possibly Venus, perhaps reaching Earth. Eventually, the Sun itself will begin to die. It will shed its outer layers into space as a beautiful expanding shell of glowing gas, a planetary nebula. And it will leave behind a dense, cooling white dwarf roughly the size of Earth, slowly radiating its residual heat into the dark. The white dwarf that was once our Sun will cool for billions of years. It will dim gradually from white to yellow to orange to red to infrared until at last it becomes invisible. Every white dwarf that has ever formed is still glowing somewhere, still slowly carrying the warmth of its stellar life outward into space. About 4 billion years from now, our galaxy will begin merging with the Andromeda galaxy. The two spirals will pass through each other, their stars too widely spaced to collide. But their gravitational fields will interact dramatically, forming long tidal streams of stars, triggering waves of new star formation. Over several billion years, the two galaxies will settle into a single, larger, elliptical galaxy. Astronomers sometimes call this future galaxy Milkomeda. The night sky of that era, for whatever beings might observe it, will be extraordinary. Not the relatively sparse and orderly sky we see today, but a river of brilliant stars extending in every direction. As the remnants of two spiral galaxies slowly become one, further into the future, star formation in most galaxies will have declined dramatically. New stars being born will mostly be small and dim, red dwarfs burning their hydrogen so slowly that they can live for trillions of years. As the bright, short-lived stars die away, the universe will gradually redden. This era, sometimes called the degenerate era, will last for many trillions of years. Long after our Sun has cooled to a dark remnant, long after the Milky Way and Andromeda have merged, red dwarfs will still be burning slowly in the dark. Some will last for 100 trillion years. But eventually, even they will exhaust their fuel. The last stars will burn out. What remains will be white dwarfs slowly cooling, neutron stars spinning down, black holes scattered through the dark. The universe will grow colder, emptier, quieter. That sounds a little frightening, doesn't it? And then, over timescales that make the current age of the universe look like an instant, even these remnants will fade. Black holes will slowly evaporate through a quantum process called Hawking radiation, emitting a faint trickle of energy. Eventually, they will vanish too. What remains after all of that is a universe of particles moving through expanding space, growing ever further apart, in a darkness with no heat, no new events, no complexity, no life. This is called the heat death of the universe. It is not an explosion or a dramatic ending. It is a long, gradual quieting. The universe will not go out like a light being switched off. It will fade, over trillions upon trillions of years, the way an ember fades when there is nothing left to burn. There is something in this vision that could be sad, if you let it, or it could be restful, a universe finally coming to rest, a story finally falling silent. Not tragic, not violent, just complete, the way a long and full day is complete when evening comes and there is nothing left to do. You are near the beginning of that story, not the end. The universe is only 13.8 billion years old, and it will last far, far longer. You are living in what will one day be remembered, if anything remembers, as the age when the universe was young and bright and full of stars. The age of complexity, the age of life, the age when matter organized itself into things that looked upward and wondered. That age is now, this moment, this breath. The cosmic microwave background is still washing through you. Ancient light from the universe's infancy, stretched into microwaves, filling every cubic centimeter of space in every direction, including the space inside the room where you are lying. 2.7 Kelvin, just above absolute zero. For 4.5 billion years, it has touched every surface on this planet, before there were eyes to detect it, before there was life to be unaware of it, before this planet existed. It has always been here. It will be here long after tonight. Dark matter is flowing through you right now. Billions of particles streaming through the walls and the floor and your body without slowing. They interact with you so weakly that in your entire lifetime perhaps not a single one will leave a detectable trace. They pass through you the way the universe passes through most things silently, without leaving a mark. Right now, gravitational waves from some distant black hole merger are moving through you. These ripples in the fabric of space-time are stretching and compressing space. They travel at the speed of light. They have probably been crossing the universe for perhaps 1 billion years. They will continue past you, past this planet, past this galaxy, without slowing, carrying the memory of two massive objects that collided in a galaxy you will never see. Tonight, everything is passing through you. The universe, out there, is not something separate from you. At every scale, it is something you are completely inside of. The atoms in your body, the ancient hydrogen, the carbon forged in dead stars, they are not separate from the cosmos. They are the cosmos, briefly arranged into something that breathes and wonders and needs to sleep. Now let all of that settle. Let the weight of the universe settle into the ground beneath you, into the floor, into the deep earth, into the quiet rock of a planet that has been turning slowly in space for 4.5 billion years and will keep turning for billions more, long after tonight, long after all of us. You don't need to feel any of that weight. The universe holds itself. It was doing this before time existed, and it will keep doing this after everything you know has faded. You only need to rest. Let your thoughts slow toward drifting. Let the images that come be gentle and undemanding. Let your own breath carry you forward, the breath that knows exactly what to do, that has always known, that was perfected for exactly this, over hundreds of millions of years of evolution, breathing in oxygen made by ancient bacteria, filtered through lungs, shaped by hundreds of millions of years of vertebrate evolution, delivered to neurons that are now growing quieter, slowing their activity, letting the day recede, letting the edges of the present moment soften. In our galaxy, there are neutron stars spinning hundreds of times per second. A neutron star is the collapsed core of a massive star that died in a supernova explosion. About 20 kilometers across, the size of a city, but containing more mass than our entire sun. The matter inside is so dense that a teaspoon of it would weigh billions of tons. The fastest known pulsar spins 716 times per second. If you could stand on its equator, you would be moving at a significant fraction of the speed of light. The entire star, billions of tons of neutron matter, completes a full rotation faster than you can blink. These objects are real. They exist quietly in our galaxy right now. In the universe, there are places where two neutron stars orbit each other so closely that their orbits are measurably shrinking. They are losing energy as gravitational waves. With every orbit, the spiral tightens infinitesimally. Over hundreds of millions of years, the orbit decays until the two objects spiral together in a collision lasting milliseconds. In those milliseconds, the collision sends out gravitational waves powerful enough to be detected from 1 billion light-years away. And in the extreme conditions of the collision at temperatures and pressures no stellar core can approach, heavy elements are forged. Gold, platinum, uranium. Every gold atom on Earth was made this way. In a neutron-star merger that happened somewhere in the history of our galaxy, long before our solar system formed. The gold in jewelry, in electronics, in the faint veins running through rock debris from a cosmic catastrophe that occurred before the sun was born. Given long enough timescales, violence becomes treasure. The cosmic web, the large-scale structure of the universe, is one of the most beautiful things that exists in a way that mathematical structures can be beautiful without being seen. Mapped across billions of light-years, the distribution of galaxies forms a pattern of filaments and nodes surrounding vast empty voids. This structure grew from quantum fluctuations in the universe's first moments, small random variations in density, amplified over billions of years by gravity. The cosmic web is what happens when gravity is applied to a nearly uniform distribution of matter over 14 billion years. The answer is a complex, interconnected network of matter and void, resembling networks inside a brain, mycelium threads running through soil, the bronchial branching of a lung. The universe seems to find certain shapes inevitable, branching, threading, connecting, the same geometry appearing again and again at scales separated by orders of magnitude. You are made of matter, shaped by that web. The chain of causality, from the first quantum fluctuation to this breath, is unbroken. About 53 million light-years away, there is a galaxy called M87. In 2019, the black hole at its center became the first black hole ever directly imaged. The Event Horizon Telescope captured an image of the glowing ring of hot gas surrounding the black hole's shadow, a bright orange-gold ring with a dark region at the center, the shadow of the black hole, the region from which no light escapes. The image matched the predictions of general relativity with extraordinary precision. That ancient light, carrying the signature of one of the most extreme objects in the universe, was gathered by radio telescopes on multiple continents, combined and processed by teams of astronomers, and turned into an image that anyone on the planet could look at. In that image, the universe made itself briefly visible to the creatures it had produced. The Earth is surrounded by a magnetic field, generated by the motion of liquid iron in its outer core. Invisible, but always there, a vast invisible shell, extending tens of thousands of kilometers into space around the planet. Without it, the Earth's atmosphere would slowly be stripped away over billions of years the way Mars's was. Right now, the magnetic field is active and working. Somewhere tonight, people are watching the aurora. Somewhere tonight, green and white light is moving silently across a dark northern sky, the visible result of charged particles from 93 million miles away interacting with atoms in the atmosphere. It is very beautiful, and it is happening right now. You don't need to see it for it to be real. Thank you for the time you have spent drifting through the cosmos. Good night. When you wake, the stars will still be shining,